Hey everyone, Ronak this side. I hope you all are doing well. So let's see the problem of the day. So the problem here we are given is create the binary tree from the description and what the description contains. So description is an 2D array which contains a node as a sub array and that sub array represents. So for example, here we are given at is 20, 15, 1 and 20, 17, 0. Okay, so these represent the value of node. These represent the value of value of a connected child, and these represent is it connected left or not, okay, in binary tree. So what we have to do, we have to construct the tree by these descriptions. So what we are going to do, we are going to first create these nodes in tree node. So first of all, we are going to create this node tree node and store it in a unordered map to search it and connect it later. Okay, so first create these nodes, and then store it in our hash map and then search it and then connect it. Okay, so first we are going to create hash maps. So we are going to create the unordered map containing the value and the address of that node, called it nodes. We have this, so we are going to first create the nodes. So first let's we are not going to, like, look here, we got 20 twice, so we are not going to create twice. So first we have to search. So tree node equal to nodes of that. Or consider we are given that description array. This is description of that index of that index what we are searching from, 0, 1, 2, and this is gonna become first, zeroth index. So if we got this value, we are going to get that address, and if and similarly we are going to search for the second child that we had already have that child. I mean our nodes list. So nodes, we are going to description of that at index. We are going to search for child. And if we got this, we got the address of node and child. We have to simply connect it. And if we haven't got it, we have to create. So if node equal to null pointer, we are going to create node equal to new tree node that has that value, description of ith index of first, and add that on our unordered map. So we are going to do description of in nodes, description of I of that 0 equal to node. We are going to add that. And similarly for child, if child is null pointer, we are going to do the same, just replace 0 by 1. Okay, just replace 0 by 1 and same. So after that we have inserted, now we have to connect this. So if description of that index is is left equal to true, we're gonna connect it to left, node left equal to child, and else we're gonna connect, if it isn't left, it's gonna become right. So we're gonna connect node right equal to child, and after that we simply have the tree, and we have to return the a2 and -1, and we have to return the root. So to return the root, what we can do is we have okay we can do is have another unordered map that contain ints and boolean type, is it child or not, and call is child, And whenever we got a child, so what we are going to do, like here we got a child, so what we are going to do, mark, I mean, is child of that value, description of I of 1 equal to true. Okay, so it is child. And how we are going to return that? For I to n, if at any case, if is child is false, I mean, is child of that description I of, if we got, if we hasn't found any of index, that is, and that is, if we found any value that is not in the child, we are going to consider it as a root and gonna return this value. So we are going to return nodes of that index, and that gonna return, I mean, we are searching for nodes. If we found any node that is not in the child, we are going to return that node, and it's gonna return the address of the node. At last, if we haven't found any such, we're gonna return null pointer. So that's simply the whole code. So let's code it and see. So here we go. First of all, let's create the unordered map. Unordered, O-R-D-E-R-E-D, unordered map. Unordered map of int that gonna contain value and tree node that gonna contain the corresponding address. Call it nodes, and it gonna contain the value and boolean, and I called it is child. And now iterate over every element. So call this as, wait a second, so iterate over, शांत रहो थोड़ा देर अभी. So let's iterate over every array. Int I equal to 0. Wait a second, I equal to 0, I less than this size of the description, and to increment the I, and then we're gonna search for every index. So we have to first initialize tree node. So we are going to search, I mean, create the tree nodes, called it node equal to, first search it in nodes. Does we have description dot I of the value, I mean the zeroth index, and similarly for the child, tree node child equal to nodes description dot I dot 1. And now we are going to do this if we haven't found any, if node equal to null ptr. If we got node as null pointer, we are going to simply create a new node equal to new tree node, with the value description of I of 0, and gonna store that in our nodes unordered map, nodes of description of I of 0 equal to node, and do the similar for the child node. If we got child as null pointer, child equal to null ptr, we are going to create a new node for child equal to new node, new tree node with the value description, the second index, I mean first index, hold on, first index, and gonna store that in our nodes unordered map, description dot I dot 1 equal to child. Okay, And after getting child, we're gonna mark child as this is child, that value is child. So we are going to is child of that value, that is, I mean, description of I of 1 equal to true, and we simply have to connect. So if is it left, so description dot I dot 2, if it's left, we're gonna simply connect it to its left. So we are going to do node of left equal to node of left equal to child. We connected child to left, and if it isn't, I mean, left, so we are going to connect it to the right. So right of the node, gonna child, and at last we have to simply search for the root. So for int for auto x in description, if at any moment we got anything, we got any as that which whose, I mean, we got any description whose value is not equal to child, I mean, whose value isn't in child, that is false. So we're gonna simply return that from nodes. So we are going to get the address, I mean, x of 1. Okay, and if we haven't found any root, we're gonna return the null pointer. So let's see if it's working or not. Hold on. I think we checked for only child, so the parent never gonna occur in child. So we have to check for parents if the parent node isn't. So for if we checked for parents, okay, so we got accepted. So let's submit the code and see if it passes all test cases or not. So yeah, it passes every test case successfully. So I mean, that's it for today. I hope you like this video. So please make sure to subscribe to Tensor. Till then, keep smiling, keep cooling.